name is Marcela Millara, and I lead software supply chain security research at Intel Labs. To set the stage, let's start with what a software supply chain is. Think of the food supply chain. When a restaurant serves a specific dish, raw ingredients are first sourced from various farms. These ingredients are then processed before they are shipped to markets. At the restaurant, cooks then follow a specific recipe to transform the ingredients into the final dish that is served to customers. Creating a software product today actually follows a very similar pipeline. Developers write source code for a new software component, which is tested and shipped, so software vendors can transform several components into their final product. With this analogy in mind, you can hopefully start to see why auditing the software supply chain matters. If we look at some key data points, recent incidents such as the SolarWinds hack and Log4j are just a few among the hundreds of supply chain attacks recorded over the last 2 decades. Each of these attacks reached hundreds of users and organizations, costing them an average of over $4 million each time. This is why cybersecurity experts in government and industry have been promoting practices including open sourcing code, collecting software bills of materials or SBOM, and generating provenance information to gather insights into how software was created. However, these current practices don't enable consumers of software to easily check if code will behave safely, or if the pipeline that produced it had the expected security properties. To help solve this problem, we developed an open specification called Supply Chain Attribute Integrity, or SCAI for short. SCAI is a simple data format for expressing claims about properties of code and software development pipelines. So if you want to check if a software product can be trusted, SCAI helps to answer specific security questions about the supply chain, like, was this binary compiled with memory safety features? Or did my CI/CD pipeline run in the expected compute environment? To achieve this goal, the SCAI format couples verifiable evidence with attribute information to back up the claims, giving consumers extra data to help them audit the supply chain more closely. These claims are meant to complement other information like SBOM or provenance, and we've been working with the open source community and industry partners to integrate SCAI into existing widely used tools. Last summer, we contributed SCAI as an attestation predicate to Intoto, a CNCF project which provides a standard framework for generating and verifying different types of attestations about the software supply chain. We've also begun to use SCAI in our ongoing project through the Open Source Security Foundation to augment the SALSA framework. SALSA defines the requirements for recording build provenance and attaining specific security levels in a supply chain. So here, we're using SCAI to collect extra attributes about the hardware and compute environment of CI/CD pipelines. We leverage technologies like confidential computing to obtain hardware-rooted attestations as evidence. With SALSA and SCAI, users can then gain trust that their pipeline was not compromised. Now, to give you a better sense of how software supply chain auditing works in practice, say we want to release a new version of my team's software as a Docker container. The CI/CD pipeline you see displayed with code push, build, and packaging steps will hopefully look very familiar. We've also added support for collecting SALSA provenance, SCAI, and SBOM information in the Intoto attestation format. What you're seeing here is the log for a GitHub Actions workflow we triggered to build and package our application. Our pipeline collected an SBOM showing the components of the final container and recorded the build process in a SALSA provenance attestation. We also want to show that this new version of our application meets regulatory compliance requirements. So we collected a SCAI attestation pointing to the provenance and SBOM documents needed as evidence. On the user's end, she can then run the Intoto attestation verifier, which is currently in prototype, to check the new container. Though I won't go into the details, supply chain auditing involves verifying digital signatures on the collected attestations and inspecting them against several policy rules. The checks pass, so our application meets the user security and compliance policy. That concludes our demo. You can learn more about Intoto, SCAI, SALSA, and our hardware-tested builds project at these links. Whether you're a software developer, a product security champion working to establish a secure SDL process, or a sysadmin making sure our build systems are running, I hope you gained a better understanding of the importance of detailed software supply chain auditing. Thank you for watching.